and you multiply the entire expression by the least common denominator. So multiply this times this. And this is common that we are doing when you want to eliminate fraction. This is classical in algebra. So when you have an equation or expression, whatever, that involve fraction, and you want to clear the fraction, you multiply everything by the LCD. It's obvious that when you multiply LCD by the left-hand side, everything is cancelled. X plus 4 is cancelled. X minus 3, X stay alive only 5x minus 1 equal a x minus 3. Why? Because I suppose that x plus 4 is cancelled with the x plus 4 and stay alive x minus 3 times a, no? Likewise, or similarly, look, be a multiplication by x plus 4, no? Because and when you multiply LCD again by the last guy, x minus 3 is cancelled and stay x plus 4. No surprise, it's obvious. It's obvious que when you multiply any expression that contains fraction with the least common denominator, we obtain a new expression that is easier than the original and do not contain fraction. Okay, so there are many ways to manipulate this. Okay, one way is can you distribute again? Okay, ax minus 3a plus bx plus 4b. This is one possibility. Is the only possibility? No, I want to explain another. And you combine like term. This is x contain variable. So this is a plus b x. And you have the term que do no contain variable, que es minus 3a plus 4b. Entonces you have in the left hand side one polynomial degree 1, and the right hand side will have another polynomial degree 1. So you can associate, see this polynomial is the same, it's equal sign in between. It's because a plus b fi. And this guy is exactly the same this guy. And minus 3a plus 4b is equal negative 1. Okay, and you have in this moment two linear equations and two unknown, the unknown is a and b. So this is the reason that we study this topic in this chapter, because this entire chapter is dedicated for the linear system of equations. So one application of the linear system of equations is partial fraction decomposition, no? And of course, the fantastic application for the partial fraction decomposition is using the application of the integration that you study in Calculus 2 or Laplace transform that you study in differential equations. You need to take that class. So remember aquí you can apply substitution or elimination. I don't know. For example, in my paper, I make a decision, multiplication by 3, the entire equation 1. What is the idea? The idea is 3 times a is 3a positive and negative 3a is positive. It's ready for elimination. So we have 3a plus 3b equal 15. No? This is my new equation 1, that by the way is totally dependent of the original equation 1. But now it's ready for elimination. When you add 1 plus 2, this is gone, this is 7b, and this is 14. Divided by 7 both sides, b is 2. I'm going to find the a value. You use this side, plugging in the easier equation, in my opinion is the first. So a plus b, que b I know is 2, is equal 5, therefore a is 3. And we get exactly the same result that we are doing at the beginning. But at the beginning, we are doing backward. We are doing, you have two fractions and you condense in only one. And now we are doing a reverse procedure. So you have one compact fraction and you need to break it down in elementary partial fraction decomposition. Okay. This is the only way to do it. No, I want to explain 4 different ways. Okay, this is the first one, is using system of equation. However, I can take advantage another way, easy way. Suppose that after the multiplication by the least common denominator, the expression that we have is this. Okay, I want to copy again. This line. Just copy. But instead of apply distributive property and complicate my life, obtain a system of equations. No. I want to evaluate this expression in one smart value. What is a smart value? Well, suppose a smart value is 3. Why 3? Because when you plug in x equal 3 here, 3 minus 3 is 0 and disappear the a part. So we have 5 times 3 minus 1 is equal a 3 minus 3, que es obvio que es 0. I create this condition intentionally to destroy a, and we have b 3 plus 4. Entonces this is 15 minus 1 is 14. This is 3 plus 4 is 7. Wow, b is 2. Super easy. I'm going to find the other. Well, we are using another smart value. Okay, another smart value is -4, x equals -4. Because when you plug it in here and the original, this is the original. Okay, you plug in -4 here, -4 and +4 is 0, no? So we get the a value using a smart value equal -4. So for example, 5 times -4 plugging in -4 minus 1 is equal a -4 minus 3 plus b -4 plus 4. Well, -4 plus 4 is 0. This part disappear. And stay alive. This is -20 minus 1 is equal -4 and -3 is -7. This is -21 divided by -7 is +3, is the a value. And we get exactly the same without using system of equation. Do you see what, professor? Entonces I always do it in that way. Well, okay, relax. You are doing in that way when you have available the smart value. But not always is possible to find the smart value. Okay? And you see in your moment why. It's the reason that it's not possible. The smart value. Okay, another way. This is very famous problem. Partial fraction decomposition is very famous problem throughout the history of the mathematics. Entonces, Heaviside is the last name of the one famous mathematician, Heaviside. Heaviside created one method that some people call Heaviside cover-up method. Okay, what is the idea behind the Heaviside cover-up method? Well, the idea behind Heaviside cover-up method is you take the left-hand side. The left-hand side in our problem, in our original problem, que is this problem, okay, forget the beginning, is only partial fraction decomposition. The left-hand side is you take 5x minus 1 over x plus 4, x minus 3, Okay, I want to do the partial fraction decomposition, no, of this left-hand side, no, fraction. So, the formula for the heavy side cover-up method is you take the left-hand side, and you cover up, for example, you cover up the factor x plus 4. And you evaluate at x equal -4, is the value associated with this. So when you take the left-hand side, you cover up, stay alive 5x minus 1 over x minus 3. And you plug it in -4. So you have 5 times -4 minus 1 divided by -4 minus 3. This is exactly the same I did before, -21, -7. The answer is positive 3. And by the way, this is A or this is B? I don't remember. Well, this is the partial fraction associated with the x plus 4, no? That was the factor I cover up. This is A. A is 3. This is A. Sorry, this is A. And B is exactly the same formula. It's left-hand side, cover up the factor is x minus 3, and you evaluate at x equal 3, is, by the way, the smart value, no? So when you cover up x minus 3, stay only x minus 5 divided by x plus 4, and you evaluate at -4. In this case, you evaluate at positive 3. We have 5 times 3 get 15, minus 1 get 14, divided by 3 plus 4 get 7, 14 divided by 7 is 2. And we get exactly the same value. So we have 3 possibilities, guys, and you, I don't know. I accept in the test any option. Using the smart value, using cover up heavy side, or you love system of equation, you set out the system of equation and you solve the system of equation. But I have more good news. Do you remember that we studied in one moment Wolfram Alpha? You remember or you don't remember? Wolfram Alpha is a software that is available online for the symbolic mathematics. So we can solve everything. We can solve equation, we can solve system of equation, you can. I want to use it in your moment when it's super complicated. You don't remember, Sean? Okay, don't worry. Now I want to show you. Okay, look at that. You open Wolfram Alpha. You open your browser. You open, for example, Google Chrome. I like Google Chrome, and you put in the address. You put Wolfram Alpha, and you select specifically the mathematical part, and more specifically the algebra part. Okay, now you see something like that. Do you see Wolfram Alpha? Okay, this is really amazing. This is really amazing. And the mathematics, I don't know if you want to study pure mathematics or you want to study engineer. Entonces you don't need to solve everything from the beginning. No. You support in different technique. And sometimes, for example, in calculus 2, there are problems of the partial fraction decomposition. Okay, the student spent 2 weeks doing that because it's too heavy, too long, crazy. However, in Wolfram Alpha, look, in Wolfram Alpha, when you open algebra, you select any, for example, any equation, no? And you type inside this box, PFD. What means PFD? Partial fraction decomposition. And be careful with the parentheses. And you typing the, okay, we have one big parenthesis that can close everything. a PFD like a function, no? So you copy the top part and close on the another inner parenthesis, 5x minus 1, close the parenthesis, division, x squared, the classical symbol of the power in any calculator gets this symbol, okay, x squared plus x minus 12, and you press enter here, bang, compute the input, bang, and you get this answer. It's exactly the same the answer that we computed before without anything. You want to see step by step, you click here step by step solution, and show you step by step, but you need to pay some money to the auction. It's completely free when you get the final answer. However, the partial answer you can the step by step you need to pay for this. Okay, let's go to the whiteboard again. There you go. Okay. Was clear or too much information? I suppose it's too much, no? Okay. Clear. Okay, clear. Okay, now I propose you for look. We have basically in the partial fraction decomposition problem. In the partial fraction decomposition problem, partial fraction decomposition problem, we have 4 cases. Case 1. Case 1 is the most common case. It's a case that we solved in the first example. Okay, I use it like a motivation example. And you have P over Q representing rational expression, no? But Q, is important thing, Q, the denominator part, has only non-repeated linear factor. In the case that we discussed at the beginning, no? Well, suppose in this example I don't want to solve it. It's only illustrate the idea. Suppose that we have a polynomial P. I don't care what happened with the P. Suppose it's just x divided by x minus 3, x minus 2. And you break it down into partial fractional decomposition. There's a linear factor, not repeated, it's different, completely different, x minus 3, x minus 2, and you put A and B. Okay? This is the case, the most common case, is the case that we're discussing in the first example. But is the only case? No! We have another case. We have, for example, we have P divided by Q, again. Okay? Noise, I hear some noise. Bolivar, please. Bolivar.
Sorry.
Come on. Entonces P over Q, in this case, for example, what happened with the Q? Q has repeated linear factor. For example, to understand this, what means to be repeated? Suppose that we have polynomial P, I don't care. And the bottom is the important thing you need to analyze. We have x minus 2 raised to the 4th power. So we have multiplicity, 4th power. So you break it down like that. A, B, C, and D. Wow. Why too much? Because you need to repeat x minus 2 to the 4th power, x minus 2 to the cubic power, x minus 2 to the 2nd power, and x minus. Necessary to put the parentheses because we have the power 1. Okay, this is the typical format for the partial fraction decomposition when you have repeated. Okay, unfortunately, you have no one partial fraction decomposition for each factor. No, we have several, depending the power. Well, si the power is 2, we have 2 and 1. Si the power is 3, you have 3, 2 and 1. This is the typical format. And the only case, no. We have the case 3. The case 3, que is the case que we have case 3. Case 3 is when the Q contain a non-repeated, pero irreducible quadratic factor. What mean to be? Well, it's a factor, okay. Unfortunately, we cannot factorization. Typical format for this, x squared plus 4. You know it's impossible. This is irreducible. Bam, bam, bam. Quadratic factor. Because the factorization here lie in the imaginary or complex field. Another x squared plus x plus 1. That's typical. So the factorization is impossible. They are prime in the real field. So what is the consideration in the case 3? Okay, let's do it. Suppose we have this example, hypothetical. Case 3x minus 5 over, suppose we have one factor. We have another factor like that. And to see what is the format for the partial fraction decomposition. I see, wow. I see one factor that is linear. Nice. I see another factor that is irreducible quadratic. Okay. So I copy 2. I copy 1, that is x minus 1. I copy, let me erase that part. I copy another, that is x squared plus x plus 1. Unfortunately, we cannot do factorization like in linear, no? In the real field, no. Okay, so this is real. This is linear, nice. And you put A, B, C, either way. And this is quadratic, and it's quadratic, and the degree of this is 2. Degree is 2. Look the format. Degree here is what? Degree here is 0. When the degree is 2, because we cannot factorization this, you need to put something here with the degree 1. Entonces es bx plus c. So you consider 2 more constant. Entonces es degree 1 que es linear, degree 2 que es quadratic. Basically, the format for the partial fraction decomposition is as a fraction, but the degree of the top is 1 less than the degree of the top, the bottom. Degree 2, degree 1, degree 1, degree 0. And that's it, no more. No more complication. And the case 4 is very, very seldom can happen. They don't happen. Is when you have the combination, the case 2 and the case 3. So we have now, in this case 4, we have repeated irreducible quadratic factor. So we have Q, the Q is the polynomial at the bottom, contains repeated, repetition, repeated is R, repeated irreducible, wow, repeated irreducible quadratic factor. One example to illustrate this idea. Well, you have, for example, one polynomial like that, x cubed plus x squared. Basically, I don't care the top part. We focus our attention in the bottom part, denominator. Yeah, I see, wow, Look at that. Multiplicity 2 and irreducible quantity. Well, you copy again, but you copy, doesn't matter. You make a decision so you decreasing the exponent or you increasing the exponent. I like decreasing. You put 2 here and you put 1. Raised to the 1 power. Okay, you know when it's 1 power, not necessarily parentheses. Leave it like that. Entonces, in both cases, we have quadratic. Entonces, you put ax plus b and cx plus d. Okay? This is the different cases for the partial fraction decomposition. Okay. Let's see example. Any questions so far? Okay, the thing you need to understand is in the problem of the partial fraction decomposition, we have 4 cases. Let me summarize quickly. Case 1 is the most common case we see every day. It's non-repeated linear factor. Case 2, sometimes I can see. It's repeated linear factor. Case 3, yes, you can see sometimes. It is a non-repeated irreducible quadratic factor. Remember, irreducible quadratic factor is a factor that we cannot factorization, like a linear, because the factorization is possible doing but in the imaginary complex. But no, never we working with the imaginary complex because it's too complicated. And the case 4, frequently you seldom you see case 4. Okay, I bring example 2. Remember, we are doing one example only, because it was the motivation example. Example 2 now is x squared over x minus 1 square x plus 1 square. Okay, we are in front of the repeated multiplicity 2 linear. Yes, it's linear, no quadratic. Remember, quadratic equal when it's x squared plus 4, no? Si es x squared minus 4, no, because we can break it down, right? Like xx 2 plus or minus, so actually is no quadratic, it's linear. In this case, impossible to break it down, therefore is irreducible quadratic. But in this case, no. In this case, everything is linear, but the multiplicity is no 1, it's 2. So it's repeated. Okay, so you separate, for example, for the first factor is x minus 1. Well, you, for example, write like that. X minus 1 and x minus 1 squared. I don't know why. In this case, I make a decision decreasing the exponent. 1, 2, 3, 4, 5. Entonces I call A and B. Remember the idea. Si the degree of this factor is 1, the degree of the top is 0. In this case, the degree is 1 because it's linear, no? It's linear with duplicity, but it's linear. Plus, exactly the same. X plus 1 and x plus 1 squared. I put C and D. Wow, just I need to find 4 numbers. A, B, C, and D. When you find the 4 numbers, we finish. End the story. Okay, so I recommend doing by the smart value. So when you have no smart value, you need to use something linear system of equation, no? Or use a heavy side, but a heavy side is not good when it's multiplicity. When it's repeated, so heavy side, the limitation of the heavy side is only possible doing in the case 1. In the case 3 and 2 and 4, no. Okay, so let's do it. I find the LCD first. It's obvious that the LCD is x minus 1 squared. X plus 1 squared. This is the LCD. I multiply the whole thing by the LCD. And the left-hand side, stay alive only x squared. And the right-hand side, well, stay a, of course, and the first guy, at least x minus 1 is cancelled one time, and stay alive 1x minus 1 and x plus 1 squared. Do you follow me? It's super easy. So mentally, you suppose that this, no, that this is cancelled with this. And stay x minus 1 and x plus 1 squared. Plus b. Similar. Well, no, similar, no. X minus 1 squared cancel out completely. So stay only x plus 1 squared. Plus c time x plus 1 one time, stay only 1, and x minus 1 squared. Plus d x minus 1 squared. Everyone saw that or no? Was complicated or was easy? It's easy, it's elementary algebra, no? The basic, okay, easy, piece okay, Jasmine say. Okay, to say I have a smart value. Yes, I have a smart. Remember the idea for the smart value is I need to select one value, okay, at least make it 0 some factor, no, in order to make easy my life. So one smart is 1. I suppose, no? You plug it in 1 here, 1 squared is 1. And when you plug it in 1 here, it's obvious to disappear that part, 0. This no. This no. This no, because it's b, 1 plus 1 squared. But this is gone, and this is gone when you plug it in 1. So stay b alone, and 1 plus 1 is 2, and 2 squared 4. Therefore, the conclusion is b is 1/4, 1/4. End the story. I found b. I have in my hand b, 1/4. Another smart value is -1. Okay, it's -1. It's -1 because -1 squared. So remember, in the left-hand side we have x squared. Now, when you evaluate -1, let me see. That part again is 0. That part again is 0 because -1 and +1 is 0. That part again is 0, and stay alive only this, que es d minus 1 squared. Okay. Therefore, similarly, -1 squared is 1, and -1 and -1 together is -2, and -2 squared is +4. Therefore d is 1/4 again. Okay. Very well. So I have in my hand B and D, but I need to find A and C. But unfortunately, we have no smart value. We have no more smart. Remember, smart value is the value that when you plug it in, at least eliminate one part. Entonces make it easy. My problem, no? I want to copy again. This expression. But unfortunately, we have no more smart value. Pero I call one frame value. What is the frame value? Well, frame value is not special. It's good, but it's not special. It's totally arbitrary value of the x. Okay, you plug it in here, and that's it. But under the consideration que B I know, que es 1/4. So this information is clear, and D is 1/4 also. And so you take totally arbitrary frame value. But of course, you take easier. No 100, 3000, no, hello. X equals 0, I like so much. This is my preference frame value. When it's 0, so we have 0, 0, 0, 0, 0, 0 squared 0. And we have A times 0 minus 1, 0 plus 1, plus 1 over 4, 0 plus 1 squared, plus C, 0 plus 1, and 0 minus 1, no? And 1 quarter, 0 minus 1 squared. Okay, let's do it step by step. 0 is equal, this is -1 actually, and this is +1. So it's -8. Negative. Negative. We have here plus something. We have 0 plus 1 is 1. 1 quarter. Good. Plus, this is again -1 because it's +1 and -1. This is minus C, minus C, minus C. Minus C, minus C. Minus C or plus C? Let me see. No, it's minus. Let me see. 0. Es minus. No, coño. I forgot here square. I forgot here square, right? Look at that. Entonces, actually, 0 minus 1 is -1, but when you square, become positive. Entonces, it's positive. Plus something, plus something, plus something. 0 minus 1 is -1, square is 1, is 1 over 4. And my equation is, you know, let me see. 1 over 4 plus 1 over 4 is 1/2. So we have 0 is equal minus A plus C plus 1/2. Let me write, because in this moment I have two unknown. I suppose the continuation of this problem is a system of equations. No? You copy C minus A, 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 positive C minus A is equal minus 1/2. So you change the sign, A minus C is equal positive half. Okay, I keep this like a one first equation. Okay, this is the frame value. Don't give me directly the answer for the one coefficient ABC, no. Give me a relationship between two factors. Therefore, you consider like one equation, no. So using another frame value, I suppose that when you plug it in here, you obtain another equation that stay a relationship between A and C, no? Suppose I take X equal 2. Okay, what is the reason I take 2? Well, because 1 and -1 is smart. I used this before. You take 2 or 3 or -2, I don't know exactly. Okay, you plug it in 2, let's do it quickly because it's too easy. Just plug it in, it's 4. It's 4. Guys, do you think this is too long? Y I select elementary examples to illustrate this today. And the calculus 2, wow, it's too heavy. However, remember Wolfram Alpha, que is our friend, to solve any problem. Okay, entonces we have A. A, and you plug it in 2. Entonces we have 2. 2 minus 1 is 1. And 2 plus 1 is 3, no? Entonces 3A, no? 3. No, because it's a square here. Sorry, this is a square. By coincidence, I get the answer. So when you plug it in 2 minus 1 is 1, and 2 plus 1 is 3, 3 squared is 9. Entonces 9, the coefficient here is 9. Plus something, plus 9 over 4. Where come from 9 over 4? Where 9 over 4 come from? Because 2 plus 1 is 3, square is 9, 9 over 4, good. And C is 3C. Why 3Z? Because it's 2 plus 1 is 3, 2 minus 1 is 1 squared, entonces 3. Plus, 1 quarter, 1 quarter. Why 1 quarter? Because it's 2 minus 1 is 1, 1 squared is 1. Okay, this is my equation now. Okay, so you combine like term, you combine like term, actually is 9A plus 3Z. So you combine 9 over 4 and 1 over 4 is 10 over 4. 10 over 4, just 10 over 4 plus 10 over 4 equal 4, ¿no? Entonces 9A plus 3C is equal 4 minus 10 over 4. And 10 over 4, this is 16 over 4 is 6 over 4, no? This is 16 minus 10 over 4 is 6 over 4. Reduce the lowest term, 3 half. 3 half. It's 3 half. Okay, 3 half. And this is my second equation. 9A plus 3Z equal 3 half. And this is my second equation. Okay, not bad. In that moment, I have two equations. To unknown. I solve this by the traditional way, you know. For example, I make a decision, I don't know if it's good or no, to apply equation 1, equation 2. I make a decision to apply elimination, I don't know why, and multiplication by 3, this equation. What's the intention? 3 times C is 3 negative 3C. So 3A minus 3C is equal 3 half. 3 half. Okay, this is my new equation 1. Ready? This is 12. This cancel out. And 3 half plus 3 half is 3. Divided by 12 both sides. A is equal 1 over 4. Wow. So at least I have que A is 1 over 4. Wow, everything is 1 over 4 in this problem, coño. Okay, now in order to find the C, easy. See, A is 1 over 4. I plug in a substitution in the first equation, because in my opinion is the easier. 1 over 4 minus C is equal 1 half. So 1 over 4 minus 1 half is equal C. Therefore, C alone is negative 1 over 4. Okay, the only guy gets different is C, okay, is negative 1 over 4. Okay, and the answer for the partial fraction decomposition is negative 1 over 4. Entonces, what is my final answer? What is the way que frequently we put in calculus 2? Well, in calculus 2, you can leave it like that, but I prefer that way. Look, the first fraction is x minus 1. And A, I know is 1 over 4. I put a 1 here and 4 in the bottom. It's equivalent. Yes or no? 4 in the bottom. Yes, Sean. Plus x minus 1 squared, 1 over 4. Minus, because the third one is negative, 1 over 4, x plus 1. Plus 1 over 4 parenthesis x plus 1 squared. And this is my final answer. This is my final answer in algebra. But this is just the beginning in calculus 2. So in calculus 2, okay, you have the original expression, the horrible original expression, okay, this. And using the algebra, you manipulate and convert to the partial fraction decomposition. This is algebra. And this is the moment to start calculus. Calculus 2. Okay? Clear or confusing? Any question? Any question? Any question? Clear. Okay. Entonces we're using, remember, we're using smart value and we're using frame value. To complete the picture. It's one possibility. Okay, let's go to example 3. In example 3, okay. We saw another idea, x squared plus 2x plus 3. We have in the bottom x plus 1 and x squared plus 2x plus 4. Okay, by the way, this is irreducible quadratic. This guy. One fantastic way to verification quickly, que es irreducible quadratic. You suppose A is 1, B is 2, and C is 4. And you apply discriminant formula. B is 2 squared minus 4 multiplication by 1 multiplication by 4. Okay, C, this is 4 minus 16. It's negative. This is negative. It's because the solution for this quadratic is complex. Si es complex, entonces es irreducible quadratic. Clear? Then, the format to decompose or break it down, this expression is, when we consider a combination, not always happen the case 1, case 2, case 3, case 4 separately. No, in this case we have linear and irreducible quadratic non-repeated, both non-repeated. It doesn't matter what you put x first, x plus 1 maybe, and x squared plus 2x plus 4 secondly, you put a and b, bx plus c. Remember, degree 2, degree 1 in the top, degree 1 in the bottom, degree 0 on the top. This is the typical format. Good? Okay. Now LCD. LCD is obvious, que es the denominator, the entire denominator, que es x plus 1, x squared plus 2x plus 4, multiplication whole thing by the LCD. So you have in the left hand side x squared plus 2x plus 3 because everything is cancelled. Entonces we have 8 times and stay x squared plus 2x plus 4 plus bx plus c multiplication by x plus 1. Okay, this is my expression without denominator. After the multiplication, this entire expression by the LCD. I multiply everything. Wow, everything by least common denominator, one by one. Okay, immediately analyze. We have frame value, we have a smart value. Yes, we have a smart. What is the only smart case we have is -1. -1 is our smart. Is -1. Because when you plug in -1 here, becomes 0 that part. And -1 squared plus 2 times -1 plus 3 is equal 8. -1 squared plus 2 times -1 plus 4. And that part is 0 because -1 plus 1 is 0. I don't care that part. 0 times anything is 0. That's the reason que es a smart value. Okay, entonces this is, let me see, this is 1 minus 2 plus 3. This is 2, no? Because 3 plus 1 is 4, minus 2 is 2. This is 2. 8 times something. 8 times, this is -1. Square is 1. Minus 2 plus 4. And 4 plus 1 is 5. Minus 2 is 3. O sea, es 2 equal 3a. Therefore, a is 2/3. I got it. 2/3. 2/3 here. 2/3. I need to find then B and C. But unfortunately, we have no smart value. We need to use in frame value. The frame value, the nice frame value is 0. When you plug in 0 in the left hand side, it's obvious 3. When you plug in 0, well, you keep in mind that this is 2/3, A is 2/3, we compute before. Multiplication by 4, because this and this disappear, and this disappear. Okay, so stay alive, you see multiplication by 1, because 0 plus 1 is 1. Oh, easy. Easy equation. Okay, and the only thing you should do is solve for C. Entonces, multiplication, this is 3 is equal A over 3 equals C, therefore, plus C, sorry. Therefore, C alone is 3 minus A over 3. This is 9 minus A over 3. This is 1/3. So C is 1/3. C is 1/3. Good. I need to find B. For finding B, well, maybe it's a little bit more complicated. I need to use another frame value. But I take advantage. I have in my hand the value for the A and C using 1. Because remember, smart was -1, but 1 is a frame. When you plug it in here, 1 is 6. It's obvious, right? Because it's 1 plus 2 plus 3. A is 2/3. Multiplication by 1 plus 2 plus 4 is 7, no? 7. Plus B, I have no idea. B times 1/3. B times 1/3. B times 1/3. B plus 1/3. Multiplication by something. What is the reason the 1/3? Okay, 1/3 here, 1/3. 1/3. B plus C, que es 1/3. A ver, where is C, C is 1/3. Multiplication by 2. Because 1 plus 1 is 2. Okay, nice. So we have 6 is equal 14 over 3. I break it down this like 2b plus 2/3. And 2/3, 6 plus no equal 14, and 2 is 16 plus 2b. Now b alone is 6 minus 16 over 3 equal to b. This is 18. This is 2/3. 2/3 equal to b divided by 2 both sides. You divide by 2 both sides. Es obvio que es by 2 both sides. Es obvio que b is 1/3. I finished. I have every value of the solution. Okay, entonces, what is the final answer? Well, the final answer is expressed in elegant way, like a calculus 2 we need, is 2 over 3 x plus 1. And b is, I forgot, b is 1/3 and c is 1/3. This is a coincidence, pero no always happen. Ok, entonces b, que es 1/3, entonces es 1/3. So you can separate. You put x squared plus 2x plus 4, 1/3, plus 1/3 again. But wait a second. This is x here. Okay, this x. And this is 1, just 1. X squared plus 2x plus 4. And this is the answer that we need in calculus. Okay. Okay, you know, it's no hard, but it's long. In the long thing in mathematics, everyone making a mistake. Okay, therefore, my recommendation is using Wolfram Alpha, no? Anytime you need to, I don't know, see the teacher. Well, in my test, no, in my test you need to show me the word because it's algebra, no? But si suppose I teach in calculus too, I don't care. I don't care this. EI, okay, this is one possibility, right? Or you see that the denominator is the same here. And you put 3x squared plus 2x plus 4. And the bottom you put x plus 1. I don't know exactly what is the most convenient way to separate in two or put together it like that. Depending the calculus too. Depending the calculus too. Option. Okay, curiosity, just curiosity. Let's put this example in Wolfram Alpha to see if we get this nice answer or no. Just curiosity. Because I want to skip to another topic today. Let me try. Wolfram Alpha. Wait. I'm switching to share screen. Wolfram Alpha. Okay, this chapter, guy, you need to be familiar with several software to make easy your work. Okay, do you see Wolfram Alpha or no? Tell me, yes or no? Yes or no? Yes or no? Come on. Yes. Vance say, yes, I saw that. Okay, remember the format. PDF, partial fraction decomposition, open parentheses, open one parenthesis, and close everything in the top. In the top we have, well, unfortunately we have no keyboard, specific keyboard for Alpha. I use our computer keyboard. It's x squared power 2 plus 2x. Not necessarily put the time symbol. So when the coefficient is numerical and we have a variable, not necessarily put multiplication in between both. However, when you have two variables, supposedly you have x and y, so you put xy. Wolfram Alpha understand that xy together is one variable. And so you need the specification time in between. But when it's numerical, no. Okay, close the parentheses because I enclose in the inner parentheses the polynomial in the top. And the bottom we have two binomials. So I open another parenthesis, double parenthesis, You put x plus 1, x plus 1, close the parentheses. I suppose it's useful to put the time multiplication. Open the last parenthesis, x squared plus 2x plus 4 and close one parenthesis que two parentheses. One parenthesis can close the polynomial x squared plus 2x plus 4. Another parenthesis can close everything in the bottom. And the last parenthesis is the parenthesis can enclose everything inside the operation that I want to do, que es partial fraction decomposition. Guys, let me see if I'm doing well or not. Bam. I press the button. Ah, look at the mistake. The mistake is, okay, put it one capital X here. The one capital X, from Alpha, don't understand very well. What the hell is capital X? Press enter. Bang! We get exactly the same answer. Remember, A is 2/3, 2 in the top, 3 in the bottom, and B and C is 1/3. So they prefer put together in only one. Super. We are the best in Miami-Dade College. Any question, guy? Any question? Partial fraction decomposition. We can do another example of the repeated, but repeated is super weird to happen. But I promise that the most important cases, que es linear, not repeated, we cover again in the review package, no? We cover again in the review package. Any question? We come back to the whiteboard. Erase totally whiteboard. Boom. Today we start another topic. No big deal, super easy. Que es system of equation again. But what kind? System of nonlinear equation. We study first in 2D. I remember in 2D, we can, of course, we use Wolfram. We can use in Desmos. 2D is nice because we have our software Desmos que help us to understand everything in 2D. In 3D, it's very complicated, and we use in GeoGebra. Oh no, I don't know, or using by hand. I want to explain both ways. Okay, what is the definition nonlinear system? Definition nonlinear system. Well, si you have at least one equation that is nonlinear, the entire system is nonlinear. Example to understand this. Example 1. I don't want to solve it, only to show you the behavior. Suppose x minus 7y equal 50. It's equation number 1. And the second equation is x squared plus y squared equal 100. Equation 2, and this is our system. The first equation is obviously linear. But the second, no, because it's quadratic, because it's nonlinear. Therefore, the entire system is considered nonlinear system. Clear? Well, see, both equations are nonlinear, for more reason, it's nonlinear system. Suppose 2x squared plus y squared equals 17. And when you say nonlinear, not necessarily it's quadratic, it's any power, 3, 4, 5. Entonces the other equation is x squared plus 2y squared equal 22, no? Equation 1, equation 2. It's obvious in this case we have nonlinear both. Okay? Do you understand very well what means nonlinear system of equation? It's easy to understand. Surprise. We have two problems in nonlinear. Number one problem, we have several situations. Well, not several. We have, for example, suppose that one equation represents a circle. And another equation represents a line. Well, we have two solutions. Two solutions. Okay. Entonces, the case is that we have only one solution. No. We can, sometimes. One solution, two solutions, or three solutions, or four solutions, or several solutions. Suppose another case. Suppose another nonlinear system. Okay, the first linear system represents like ellipse, like that. Look, let me show you. Ellipse is like a circle, but it's not exactly the same radio in every direction. I promise that the last chapter we studied in detail the conic section, and we studied the ellipse in detail. And suppose that the second equation represents another ellipse, but like that. Well, so we have how many solutions? The solution, remember, and the system is the common point, the intersection. We have 4 solutions. And that's it, no. We have another possibility, is suppose my first equation represents a circle, a small circle like that. Small circle. And my second equation represents a parabola like that. So we have no solution because there are no connection, there are no common point in between the parabola and the circle. So this is no solution case. So we can find, guys, more possibility in nonlinear. Remember, in linear we have only one solution, infinity many solution, or no solution. In this case, it's very, very weird. It happens that we have infinity many solutions. It's possible, but it's very, very weird. Or no solution, or several solutions. 2, 3, 4, 5. And maybe one is possible. Okay, this is one problem in the nonlinear. The second problem is in my opinion, is the best, the worst problem is that we have no one systematic way for solving this. So we are using the classical substitution or elimination. It's the only possibility we have. But depending on the system, si es linear, si no linear. Si es linear, I prefer substitution. Or no, the combination. O sea, suppose that one equation is linear. Okay. You isolate one variable and substitution in another equation. Elimination, when it's any equation are non-linear, maybe it's possible. Maybe. And their combination. Imagination. Rule. It's crazy for solving system. This is, in my opinion, my personal opinion, this is the most complicated problem in mathematics. Solution of the nonlinear system of equations, because there are no rules. That different system is solving in different way. And maybe in one moment you don't see what is the way. Maybe tomorrow you see, I got it. Okay, but no. Okay, let me try to explain. No super complicated problem. Relative. Example 1, for example. Actually, this is example 1. Is minus x minus 7y equal 50. This is my equation 1. Okay, by the way, it's linear. And x squared plus y squared equal 100. Okay, by the way, is non-linear. Okay, then I propose you. Okay, when you see this, you take advantage the linear equation. You take the linear equation first and solve for the variable that you consider is easier. In this case, the coefficient is 1 or -1. It's -1. Entonces, you solve for x here. Then you take the first equation. You solve for x because the coefficient is 1 or -1. So you solve for y, you can, but you divide it by 7, so you introduce fraction. And maybe you complicate a little bit your problem. So you put minus x is equal 50 plus 7y. But I don't like minus x. I want positive x. So minus 50 minus 7y. And you now substitution replace this expression where? Here, I suppose. And replace x for this expression. So says minus 50 minus 7y squared. Now this 2 is this 2 plus y squared equal 100. Okay, so in this moment I have one equation, polynomial equation of course, pero contain only one variable. So I suppose que es easier. You expand this. Negative 50 squared is 2500. Okay, I know I don't care this negative because you know, okay, this negative I don't care. Why I don't care? Because you consider like a negative 1. A negative 1 squared, so you factor out negative 1 here and your square become positive. So definitely it's totally useless to consider this negative because negative inside the square becomes positive. And you square the first plus multiplication both and multiplication by 2, okay, 50 times 7 times 2 is 700. Okay, y plus square the second, okay, 7 squared 49, y squared plus y squared equal 100. Do you understand this algebra? Okay, I using that formula, guys, to make fast. Anytime I am doing this expand, you square the first plus twice multiplication both plus b squared. This is a formula. See, it's minus here and minus here. But in this case, no minus, it's positive. The square the first is 50 squared is 2500. Multiplication a and b together 50 times 7 is 350 times 2 is 700 plus b squared is 7 squared is 49y squared. Now I finish. No, we combine like term. 49 plus 1 is 50. So 50 y squared plus 700 y plus 2500 minus 100, no? Equal to 0. Because I suppose that we finish in quadratic equation the 50y squared plus 700y plus 2400 equal to 0. Well, in that moment, okay, two heavy number, I don't care. If you divide by 50, I suppose that you divide by 50, whole thing, 50, 50, 50, 50, 50, and 50, because I put in my calculator. In my calculator, I know that 50 divided by 50 is 1. Okay. 700, delete the 0, is 14. And this delete the 0 is 48. 48 equal to 0. Let me check it just in case. Is 240 divided by 5. There you go, 48. And this is my super easy elementary quadratic equation. Okay, I suppose that we can finish by factorization because the combination is so obvious que es 8 and 6. So 8 times 6 is 48, 8 plus 6 is 14, plus both. Then you find solution, y plus 8 equals 0, therefore y is negative 8. Y plus 6 equal to 0, y is negative 6. I finish. No, I need to find the x value. Remember, I try to find solution. Solution is the common point in the two-dimensional plane. Any point in two-dimensional point is defined by the order pair x comma y. So I need to find the y associated with this. The x is equal, I come back to this expression, is negative 50 minus 7 multiplication by negative 8. I'm using my first value of the y. Entonces, in this case is is 50, negative 50, plus 56, no? Is 6. Okay. Is 6. Now, the second value is negative 50 again, minus 7 times negative 6, que es 42. Entonces, x is equal negative 50 plus 42 is negative 8. Okay. Entonces, what if how are you matching that? Well, I'm matching y negative 8, que es this. And the answer was 6. Entonces, the point is 6x value, negative 8 y value. And here I plug in negative 6, que was this. Entonces es x es negative 8, comma, negative 6. I discovered que we have two common points. Okay, solution set is 6, comma, negative 8, comma, negative 8, comma, negative 6. Pero okay, the fantastic way, the fantastic. Okay, I using algebra to heavy algebra, sorry, but this is normally happening. Now, I want to verification in Desmos, this. Super easy. And Desmos is, look. You put both equations in Desmos. Okay, example 1, I'm doing. The first equation, look. Do you see Desmos or no? Tell me. Answer me. Okay, good. Sean. Thank you. Okay, I just typing the first equation in blue color, que es linear. Okay, Karen. Linear is a line. Expecting is a line. And the green one, que is a circle. It's nonlinear. And you can see the intersection, que is the famous point, negative 8, comma, negative 6, and positive 6, comma, negative 8. Okay, two solutions. Super or confusing? Any question, guys? Clear. Okay. I suppose everything is okay. One more example. Nonlinear. Remember, nonlinear, we have no rule to solve it. This is crazy. Totally crazy. Using your common sense and imagination. Imagination is important. In nonlinear. Whiteboard now. Let's move on to example 2. Let's do it. Why not? Example 2. Example 2, we are using similar strategy. Suppose 2x plus y equal 5. Wow, it's equation 1 is linear. And x squared plus y squared equal 50. Equation 2. Entonces immediately you see, well, at least we discovered some rule, no? Si es linear and non-linear, I take the linear. Solving for the variable que contain coefficient 1 or negative 1, and substitution in another non-linear. Okay, this is the rule. Okay, I discovered some rule. So I know that y is equal 5 minus 2x. And substitution, this expression here. And the y, no? Here, and the y. I have x squared plus parentheses 5 minus 2x squared equal 50. So far, this is my problem. And you expand the binomial. Square the first guy is 25. Minus. Unfortunately, it's minus because it's minus in between. Entonces es 5 times 2 is 10 times 2, 5 times 2 is 10 times extra 2 is 20. 20x plus square the second get 4x squared minus 50 equal to 0. Okay, let me try to organize. Well, we combine later. Combine later. This is 1, this is 4, this is 5. 5x squared minus 20x minus 25, no? Because 25 positive and 50 negative equal to 0. If you divide by 5, 14. We have x squared minus 4x minus 5 equal to 0. Okay, easy. Now, factorization. Or quadratic formula, depending on the problem, no? In this case, easy by factorization because the combination is obvious, 5 and 1, negative and positive. Okay, this one solution is x equal 5. Another solution is x equal negative 1. Ciao. Negative 1. Now I go to the expression that contains y. You can substitution in either equation, but I take advantage. And this y is isolated, waiting for me. Y is for I minus 2 times 5. Now this is 5 minus 10, this is negative 5. Okay, so I take advantage of this moment to write the point. The point was 5, negative 5. 5, negative 5. Look, this is my x value, and this was my y value. And likewise, this is 5 minus 2 times negative 1. And 2 times negative 1 is 2, positive is 7. And the point is the point negative 1, 7. And this is my solution set. Solution set is 5, negative 5, negative 1, 7. We still looking at this. Ay, sorry, carajo. Sorry. Okay. Yes, you're right. Okay, don't worry, I repeat again the idea. Whiteboard. Do you see the whiteboard or no? Okay. Okay, let me try on do. Let's do in backward. I like that way. Suppose we had doing before. Yeah, undo and redo. Okay. Okay. The first thing you should do is realize that the first equation is linear. See, the first equation is linear and the coefficient in front of the y is 1, so you solve for y. Bam. Now, substitution this expression in the place of the y in the second equation. Now I copy x squared plus parentheses. I copy the expression, replace y for this. Now expand the binomial 25 minus 20x plus 4x squared minus 50. I move to the left equal to 0 because I suppose. Okay, we finish in quadratic equation. Combine like term 5. Combine 20, well, 20, I just copy 20x and 25 positive and 50 negative is 25 negative. This and this together is negative 25. Now I see that you whole thing, the entire equation. Okay, and we have this equation, easy. Okay, we can solve it by factorization. The factor involved in the problem is 5 and 1. Negative 5 and positive 4. Positive 1. Therefore, the solution are x equal 5 positive and x equal negative 1. Now substitution that value into the any equation. However, I prefer this equation in which you have y isolated. I take that. Y isolated 5 minus 2 times 5. 2 times 5 is 10, and 5 minus 10 is negative 5. Entonces, in this moment, I take advantage to copy the solution. The solution is the order pair 5, negative. I'm using 5. Now using, okay, I take this and this together. The x value is 5 and the y value is negative 5. Similarly, using negative 1 is 5 minus 2 times negative 1. Be careful with the sign. Entonces, negative become positive is 7. And the point is negative 1, 7. Therefore, the solution set is 2 points. We discovered 2 common points is 5, negative 5 and negative 1, 7. As always, we can verification this answer in Desmos. We put 2 equations in Desmos and you see what is the common point. Let's do it now. Do you understand very well the solution? Everyone understand? Tell me yes, no, clear, confusing. Come on. Confusing, very confusing, very clear. Okay, let's move into Desmos now. You see, okay, here is Desmos. Okay, look at that. That was example 1. I suppose you are watching Desmos, no? Look at the example 1, example 2. Example 2 is a circle again. And the other line, we see, okay, yes, we see Desmos. And you see that the solution is the point negative 1,7 and 5, negative 5. Super, we are the best. One more from, we continue next time. One more, oh no, I don't know. Any question, guys? You see that Desmos is super useful to verification any system. The system that we solved so far is easy, but not always is easy. Sometimes it's a little bit complicated. Okay, I try to switch into the whiteboard. Do you see whiteboard? Good. Okay, let's do number 3. Number 3 is number 3 is, let me see, is the first equation is x minus 5 squared plus y squared equal 25. And this is my equation 1. And the second equation is y equal 3 times square root x minus 8. This is equation 2. Entonces, en nonlinear, you see something crazy equation because you see, for example, Normally, the habit that you have is in the linear system, you have the standard format. Standard plus by equals c. And the second equation is, again, a the same. One column for the x, one column. This is the typical format for the linear. But no linear, no. And the linear is crazy. In the linear, you have, in this case, I don't know why, the y is isolated. And you have a square root operation. Wow. But no worry for this. You take advantage of this. You take advantage using your common sense and your imagination that in the second equation, y is isolated. Therefore, it's ready for substitution. So use substitution, this expression is equivalent to y into the first equation, like that. And you copy x minus 5 a square plus, and now we have parenthesis 3 square root x minus a square equal to 25. Okay, now you expand this. X squared minus 10x plus 25. Good, I like that. But this no, because this is considered like a monomial expression. This is actually like a 3 cubic is 9. 3 squared, sorry, is 9. And parenthesis, don't forget this parenthesis, because now square root and square cancel out each other, right? It's x minus 8. Minus 25 equal to 0. Do you see? Be careful, because suppose 3 radical x minus a squared, you consider that this is 3. I know that square minus a squared, the square root and the square cancel out, it's done, it's gone, this is just 9. But if you write without parentheses, I believe that 9 multiply only x. This is not true. 9 multiply everything. That is the reason it's super important, this parenthesis. So x squared minus 10x plus 25 plus 9x minus 72 minus 25 equal to 0. Ready. We are ready to combine later. Well, 25 positive and 25 negative is cancel out. Negative 10 and positive 9 is negative 1. Stays 72 equal to 0. And this is my quadratic equation that I need to solve. This case by factorization is super easy because the combination is 9 and 8. 9 times 8 is 72. Somehow 9 minus 8 is 1. Negative and positive. Different sign. One solution is 9. And one solution is negative 8. Okay, in order to find the y value associated with this x value, I substitution into the, in my opinion, the easier equation, que es the second, no? Because y is isolated, waiting for me to find the value. So it's 3 times square root 9 minus 1. Wow, we discovered the point 9,3. And the second is y equal 3 times square root negative 8 minus 8. Wow, pero negative 8 minus 8 is negative 16. And square root negative 16 is not real. Therefore, that means that we have no solution. At least for this value. So I discovered that this value does y imaginary, no? And remember, when you try to find something in algebra and the answer is imaginary, it's because do not exist. Unfortunately, we have one solution, one common point. Solution set is just 1 point, que by the way is the point 9,3. Pero okay, I am not happy because I lost one solution. Okay, because I want to verification and Desmos. I want to see the geometric interpretation for this situation. Okay, let me try to go to Desmos. Switching to Desmos. Okay. Okay, it's example 3, no? Example 3. Wow, look at that. Example 3, I copied the equation. The first equation represents a circle. I suppose that you don't understand very well, but I promise that in the chapter 5, it's the last one, we study in detail circle, parabola, ellipse, hyperbola, in detail. The first equation represents a circle. And the second equation, is the red color, represents half of parabola. Why half? Because so you have positive or negative, but you have y without sign, no? I suppose the default is positive, no? So it's 1/2 of the parabola, and the common point is only one point, que es 9,3, que was my answer that I get in the algebraic way. Any question? I have 10 minutes. In 10 minutes we are doing one more, and that's it. And that's it. Okay, I'm switching again one more time to the whiteboard. Let me know if you see whiteboard or not. Whiteboard clear. Do you see whiteboard now? Yes or no? Good. This is example 4, no? Example 4 now. Example 4. Nonlinear. We are doing nonlinear system in 2 dimensions. I promise next time we are doing at least one couple of problems in 3 dimensions, que es relatively crazy. Okay, look, it's 2x squared plus 2 plus y squared equal 17. This is my first equation. Now my second equation is x squared plus 2 y squared equal 22. Wow, look at that. It's obvious that both equations are nonlinear. It's obvious then that we cannot use the traditional way of the substitution. No, impossible. Because I plan in doing by elimination. Suppose that I multiply many ways to do that. The equation number 2 by -2. What was my strategy? My strategy is, if you multiply by -2, we have -2 here. -2 is square and +2 is cancelled out. So we have minus 2x squared minus 4y squared equal -44. And this is my new equation 2. Yeah, I forgot temporarily, of course, this old equation 2. Yeah, I focus it in the equation 1 and equation 2 new. This is cancel out. This is -3 y squared equal, this is 44, 27, no, -27. Divided by -3 both sides. Y squared is equal 9 positive. Okay, quadratic equation, but easy. Solving by square root. There's a y alone is equal plus or minus 3. Okay, don't forget plus or minus. Always when you have component, now see you have this time, no, it's only positive. But if you have component x or y, you consider the plus or minus always, no? Now in order to find the x value associated with this, well, you take easier equation, in my opinion. Mira, I erased this equation, okay? In my opinion is the easier. I use it again one more time. 2y squared equal 22, no? If you take this equation, okay, I erase here, and substitution 3 here, look, x squared, one by one, no? Actually, we have 3 positive and 3 negative, no? And substitution one by one here. But okay, no necessary, not necessary. Look, 2, so you put plus or minus 3 squared. You evaluate both simultaneously, because regardless, si es positive or negative, of course, we have When you square, become positive, no? Entonces, x squared plus 3 squared is 9. Si es negative 3, it's always 9. Times 2 is 18. Okay, therefore, x squared is 22 minus 18, que es 4. Okay, again, one quadratic equation similar to this, apply square root, entonces we have plus and minus 2. Entonces, 2 positive and 2 negative. Entonces, how many points in total? Well, I suppose que we have 4, que es their combination. I suppose que the solution is 2,3, both component positive, I take this and this. Both component negative, and their combination, positive and negative, negative and positive. Sure, 2, 2, 2, x is 2. 2 and 3. Positive, no? We have 4 points. Okay, but to make sure that we are doing well, no, let me put in Desmos one more time. Okay. Do you see Desmos? Okay, that was example 3, Now example 4, look at that. Example 4, let me make a zoom to understand better. We have two ellipses. The equation, first equation is the orange color. The second equation is the purple color. And the intersection is the combination 4 point. We have 4 solutions in this example. Okay, super. You follow me, you understand a little bit. I promise, guys, we go over again to everything in the review package. And you know my way, we dedicate one entire week, 2 weeks doing the review package. Now, do you see my face? Yes or no? You see my face now? Yeah. Goodbye. Time is over. Not over, but almost over. And we're working too hard. Bye, Yamin. Remember, now I have another class. Now, immediately when I can, I will post it, the video on YouTube. Okay, thank you so much. Your attention.